This video is going to look at when to use sine theta equals O over H, okay, which I referenced in my previous video. So, sin O H, S O H, okay. Now, we looked at this before and we said that the first thing to do is to label your diagrams. Now, if your question involves the length which is opposite the right angle called the hypotenuse, and the length that is opposite the angle involved which is called the opposite, and there's no reference to this length here which we reference as the adjacent, then we use this, sin theta equals O over H, because the question involves an angle, theta, O, and hypotenuse H, okay? So we reference it as sin theta. Okay, so these are three different examples where we can use it. So example number one. First thing that I've told you to do when you see a question using with a right angle and an angle involved is to label up your diagram. So the first thing to do, remember, is to reference the length opposite the right angle, which we call the hypotenuse. Then the other length involved is this one, which is opposite the angle involved, so that is O, and then we have theta, which is 50 degrees. So the first thing I'm going to do is I'm going to write out what I've got. So I've got theta is 50 degrees, O is what I need, and H is 6. There is no reference to this length at all in the question, the adjacent, so therefore I'm ignoring it, and that's why we choose sin theta equals O over H, because it involves theta, O and H. Theta, O and H, therefore I use sin. So then I'm going to write out the formula, sin theta equals O over H, and I'm going to substitute my numbers in. So sin theta is 50, so sin 50 degrees equals O, which we don't know, so I'm going to just reference it as O, divided by H, which is 6. Okay, now I need to rearrange this formula. So just like other rearrangements, if I would need to move this to make O the subject of my formula, I'm going to have to multiply it across the equal sign, because it's dividing the O at the minute, so I need to do the opposite, which is to multiply. So O equals 6 sin 50 degrees. And the last thing I need to do is take out my calculator. Apologies for the really old calculator I'm using today. 6 sin 50 equals, and that gives me 4.6 to 1 decimal place. Okay, so that's the first one, a pretty simple one to look at. Second example. So again, start by referencing the triangle to start with. So opposite the right angle is the first one we're going to label, which is H. Opposite the angle is O. And then we have the angle theta, which is 25. So write out what we have. Theta equals 25 degrees. O equals 3. H is the thing that we don't know. Again, no reference to A, so our question just involves an angle. So theta, O, H, H. So that's why it's again sin. So sin theta equals O over H. Substitute in the numbers. Sin 25 degrees equals 3 over H. Now, this time it's a little bit more complicated to do the rearrangement, because the H, which is what we need to make the subject, is on the bottom of our fraction. So I need to move it to start with by multiplying. So this becomes H sin 25 degrees equals 3. And then I need to move the sin 25 by division, because it's multiplying onto the H at the moment. So H equals 3 divided by sin 25 degrees. And if I put this in my calculator, 3 divided by sin 25, this gives me a value for h of 7.1. Now, if you want to sense check this, you should be making sure that this is the hypotenuse, so we know that this should be longer than the opposite, which it is because h is 7.1, the opposite is 3, so it is bigger. So we can kind of say that that one's fine. Okay, now the last one is when we are given a triangle again. This time we're given two lengths and we need to find the angle. That's what's missing. So again, start from the beginning, label up your diagram. So opposite the right angle is the hypotenuse. Opposite the angle is O. Again, no reference to A, so we don't need to state it. We don't need to do anything about it. So write out what we've got and what we need. So theta equals, we don't know, question mark, that's what we need to find. The O is 3 and the hypotenuse is 4. And I'm just going to reference Marina at this point because Marina, you missed this in class, so hopefully this is going to help you catch up how to find an angle. Okay, so theta, O and H, theta, O and H, sin again, so sin theta equals O over H, substitute 3 over 4. Now this is the bit that pupils don't know what to do because they think, oh, we need to divide by sin, but that makes no sense. So we have to actually move the sin. Now it's not multiplied onto theta, so to do the opposite of sin, we need to do sin to the minus 1. Okay, so theta equals, is the inverse basically to the minus 1, means the inverse of sin, which is the opposite of sin, of 3 over 4. Now, on our calculator, if we look at the sin button, then above it in yellow is sin to the minus 1, so the inverse of sin. And to do that, we have to press the shift and then the sin button, and then put in 3/4. And that will give us our angle of 48.6 degrees to 1 decimal place. So they are the 3 different types that they could give you that involve an angle, O and H, and the 3 different methods to use to find what you require.